Hello, I'm Sriram and I am presenting my paper Push-Poke Collision-Based Direct Manipulation Technique for Plane Alignment in Virtual Reality. This research work was carried out in Tauchi Research Unit at Tampere University in collaboration with Medical Imaging Center, Department of Radiology, Tampere University Hospital. This research was carried out in context of jaw osteotomy planning. Osteotomy is a surgical insertion procedure performed by medical professionals on bones to shorten, lengthen, or change their position and orientation. Jaw osteotomy are performed for roughly 5% of the world population. Performing jaw osteotomy pre-operation planning is an important task as it reduces the health risks. Jaw osteotomy planning process can be divided into 3 steps. In the first step, the points are marked on the skull. The medical professionals decide where and how to place these points based on which area to be removed or altered. Based on these points, a plane is created. In the second step, medical professionals adjust the position and orientation of the plane accurately. In the third step, they perform the cut operation to split the bone into 2 segments. The accurate positioning of the osteotomy plane is one of the most critical steps in jaw osteotomy planning as it accounts for high health risks of around 10 to 20%. Currently, medical professionals plan jaw osteotomy operations using a traditional 2D screen-based user interface with keyboard and mouse. They mentally reconstruct 2D information into 3D, which is complicated, error-prone, and requires training. Viewing 3D medical data in 3D environment reduces the 3D to 2D information loss, provides enhanced depth perception, and ability to interact with two hands simultaneously. A user expectation study was conducted with 2 medical professionals with jaw osteotomy experience. They performed the plane manipulation step in virtual reality using controllers. They were able to complete the task precisely and quickly. However, they wanted to manipulate the plane with their bare hands instead of controllers as hand manipulation was more in line with their mental model. Hand tracking in virtual reality is noisy due to occlusion, differentiating ego motion from the independent motion, and limited FOV of the hand tracking sensor. This makes designing for hand interaction challenging, especially for tasks that require precision. Jacobs et al. Defined perceptual structure as how a user perceives the modifiable attributes of the task. There are 2 types of perceptual tasks. Integral tasks have attributes that are changed together, and separable tasks have attributes that are changed independently. They found that 3D tracker is effective for an integral task of changing the XY location and scale of a box, whereas a mouse is suitable for the separable task of changing the XY location of a box and its grayscale color. Therefore, the perceptual structure of the interaction should match the perceptual structure of the task to achieve higher accuracy in less time. Previous works have investigated the perceptual structure of hand-based direct manipulation to evaluate against mouse input as a separable technique on a 2D display instead of a VR. Mouse is a well-suited input device for 2D tasks on a 2D screen, but when it comes to 3D manipulation tasks, using mouse becomes challenging as it lacks direct input method representation for depth. To overcome this, we commonly use indirect manipulation methods like gizmos, or have separate input combinations for XY manipulation and XZ manipulation. One advantage with mouse is that pointing is very accurate and well suited for precise manipulation. When it comes to VR, having mouse as an input device is not ideal. Also, there are other tracking devices like controller and hand to manipulate in virtual reality. Controller and hands are well suited for integral tasks and 3D manipulation in 3D space. But when it comes to precision, 3D devices have struggled when compared to 2D mouses in 2D displays. Some of the reasons why users struggle is that it is hard to keep the hand stable in 3D space. The partially observable nature of the problem, where manipulation decisions are dependent on the viewing angle, lack of haptics, or lack of physical constraints to guide the users. When it comes to hand-based object manipulation, gesture plays a key role to trigger a specific action. We can relate gestures to button clicks in a mouse or a controller trigger. So most of the times, users use grasp or pinch gesture to activate, pick, and release. But the optical sensors that track the hand and predict the pose of the hand are noisy and prone to accuracy error. This error is transferred to the accurate positioning of the object. One of the advantages of hand over controller is that hands are versatile and humans use different hand gestures intuitively. So we explored the task of precise object manipulation and tried to understand what is the perceptual structure of the task with hand as an input. Therefore, in this paper, we investigated the perceptual structure of hand-based Oshishomi plane alignment task in virtual reality and compared both integral and separable hand-based technique in VR. Based on contextual inquiry with two medical experts, we created a task of plane manipulation in which the user has to place a plane between two segmented parts of a cube. Literature review revealed that interaction techniques that provided users the ability to perform selection of rotation, translation, and degree of freedom separately were able to achieve high precision. So we designed two interaction techniques with two different approaches for dealing with noisy hand tracking. One, the users can select these selection of rotation, translation, and degree of freedom parameters. Or two, these parameters are dynamically selected based on users' interaction. In push-poke, the user can use their hands and fingers to collide with the object to move it in a desired direction. In push, the user can collide the object with their hand. In poke, the user can poke with either one finger or multiple fingers. We designed push-poke in which the manipulation parameters are dynamically selected based on the collision points. In custom access with CD gain, translation and rotation are performed separately. Translation handle appears outside the object in blue, rotation handle appears on the plane in red. These handles follow the hand movements. Once the user grabs these handles, a fixed axis is created. Then the user can translate along the fixed axis. CD gain is applied to scale down the movement. Similarly, user can rotate around a custom pivot point based on the pinched point. We designed custom access with CD gain widget in which the user can select these manipulation parameters. In this paper, we aim to answer these two research questions. 1. Which interaction technique is objectively accurate, has least task completion time, and most preferred for plane alignment in virtual reality? 2. Which interaction technique matches the perceptual structure of a precise plane manipulation task? To answer these research questions, we evaluated these techniques in a user study. For this study, we recruited 12 participants. The participants were asked to do the study standing up so that they could move around the cube and observe it from different angles if required. The participants had 1 meter square space around them. In this study, participants used these interaction techniques to achieve minimum accuracy of 95%. The participants could press the red button once the minimum accuracy of 95% was reached and proceed to the next trial. In this study, pinch was used as the baseline condition. We used within subject evaluation to compare these different interaction techniques. In this study, participants were presented with conditions in counterbalanced order based on balanced Latin square to reduce the effect of ordering the conditions. A total of 6 trials are used in each condition. During this task, various quantitative data related to the overall task and the individual interactions were collected. Participants were asked subjective rating on a Likert scale from 1 to 7 after each condition. They were asked open-ended questions about positive and negative of each interaction technique to gain further understanding of their perceptions. After all the conditions were completed, the participants were asked to rank interaction techniques based on different aspects. Results show that push and poke was objectively and subjectively more precise than the baseline pinch. Participants felt push-poke was easier to use, more intuitive, felt more confident in using it than the other two interaction techniques. Participants also felt push-poke was easier to learn and less tiring than custom access with CD gain. Based on these results, the perceptual structure of hand-based plane manipulation in virtual reality is as follows. The perceptual structure of hand-based plane manipulation task consists of integral and separable task. The initial large movements as an integral task and the final fine movements as separable tasks. Interactions should dynamically select degree of freedom and RT selection based on contact points for small movements. In future work, we are planning to further iterate on these interaction techniques based on the participants' feedback. We are planning to implement the following combinations. 1. 1 or 2 hand pinch. 2. Pinch and poke. 3. Pinch and rotation handle of CACD. We are also planning to evaluate these interaction techniques for jaw osteotomy planning with medical professionals. Thank you, and now I would be happy to answer some of your questions.